All right, hi everyone. So we're going to do an example for the work equation. So we have a coin slides over a frictionless plane and across an XY coordinate system from the origin to a point with XY coordinates 3 meters, 4 meters, while a constant force acts on it. The force has a magnitude of 2 newtons and is directed at a counterclockwise angle of 100 degrees from the positive direction of the x-axis. How much work is done by the force on the coin during the displacement? So first and foremost, let's just draw what's happening here. So I have my coordinate system like this. Now I'm going to do these in 2 different colors. So I have a displacement. The coin starts at the origin. So it starts here and then it slides to 3, 4. So there is my displacement here. If I draw this triangle, this is 3 and this is 4. So this is my displacement, D. And then a constant force acts on it, and the force has a magnitude of 2 newtons and is directed at a counterclockwise angle of 100 degrees from the positive direction of the x-axis. So if I draw my force, let's draw it in red, and this is 2 newtons. 2 newtons, and then we know that this whole angle right here is that 100 degrees. Okay. And then it says how much work is done by the force on the coin during the displacement. Now, your first instinct might be to break these down into X and Y components. And then, maybe find the work done in the X direction, work done in the Y direction, and then resolve like that. Now, this isn't completely what we want to do. You can do it that way, but it is a little bit different because work is a scalar. Work is not a vector. So if you did do it that way, when you got the X component and the Y component, you would then add them together. You wouldn't do like Pythagorean theorem because work is not a vector. But what we can do here is, because we know that the work equation is work is equal to force times displacement times the cosine of theta. All I need to do here is I need to find that theta. I need to find this angle right here, which is going to be the angle between the force vector and the displacement vector. Okay, so I already know what that angle is of the force vector with respect to the positive x-axis. If I can find what the angle is of the displacement vector, then I can find what the angle between them is. So let's find that angle. This angle right here is going to be the inverse tangent of 4/3 because the tangent of the angle is 4/3. So if I plug this into my calculator, I get inverse tangent of 4 divided by 3 is equal to 53.13 degrees. So that means that this angle, and let's do it in green, between the force and the displacement there, my theta is going to be 100 degrees minus 53.13 degrees. So theta ends up being 46.87. Oops. 46.87 degrees. So I have my angle now. I know my force vector's magnitude, but now I also need to know my displacement vector's magnitude. So you could use Pythagorean theorem here, but we also know that it's a special triangle, right? It's a 3, 4, 5 triangle. So we can already see that displacement is going to be 5. But again, if you want to find displacement, you could use a square root of 4 squared plus 3 squared. Again, displacement ends up being 5 meters here. So now that we have the angle, we know our force is equal to 2 newtons. We also know displacement is equal to 5 meters. Now we can find our work done on that coin. So work is equal to force, 2 newtons, times displacement, 5 meters, times the cosine of the angle between those 2 vectors, which is that 46.87 degrees. So I get 2 times 5 times the cosine of 47.8. I keep saying 47. 46.87 degrees. And we end up getting the work done is equal to 6.8 3 joules.